Good morning, students. So, in the last class, we have discussed the classification of embedded systems. Okay, so we can classify embedded systems into three categories. One is based on their generation, and based on performance and complexity, and based on their triggering. So, based on generation, as you know, we can classify the embedded systems into four types: first generation embedded systems, second generation embedded systems, third generation embedded systems, and fourth generation embedded systems. Okay, so this is the classification based on the generation. Then how can you classify the embedded system based on their performance and complexity? If the embedded system is pretty simple in its functioning, then based on performance and complexity, I can classify it into small scale embedded system. If the embedded system is slightly complex and the hardware is also slightly complex and the working is slightly complex, then I can classify that embedded system into medium scale embedded system. And the last one is the large scale embedded systems, where the embedded system will be very complex. The processor will be complex and all the programming languages used will be complex. Okay, so these two classifications we have seen in the last class. Okay, so let us go on to the next type of classification, that is how can we classify the embedded systems based on the triggering. So based on triggering, I can classify the embedded systems into two types. One is event based triggering and the other one is time based triggering. So what is event based triggering? What is event based triggering? So whenever a particular event occurs, the embedded system will be triggered. It will start functioning. Okay. So whenever I press a button, okay, it is treated as an event. Or whenever the input signal comes, their input voltage comes or input current is applied to a circuit, then the embedded system may start functioning. Okay. So whenever an event occurs to the embedded system, okay, it will start functioning. So such type of embedded systems, they fall under this category, that is event based triggering here. Okay, and the next one is time based triggering. Okay, so whenever a particular time occurs or whenever I set the particular time, at that time only the embedded system will start functioning, or I may also set the timing to turn off the embedded system. Okay, so in this way, based on the time, the embedded system will be triggered. Okay, so these two are the classifications for embedded system based on how they are triggered. One is event based triggering, other one is time based triggering. Okay, so let us move on to the next part, that is in what all the different areas I can use embedded systems. Okay, so the major application areas of embedded systems are: the first one is consumer electronics. Okay, so in this area, consumer electronics, or we call it as a domain, the examples for embedded systems are camcorders and cameras. Okay, so these two come under this category, that is consumer electronics. And the second domain or area is household appliances. Okay, in our house we use so many devices or appliances, so which are embedded systems in fact. Okay, so which are the devices appliances we are using in our house? We are using micro oven, we are using washing machine, we are using DVD player, we are using smart telephones. Okay, all these appliances are examples for embedded systems which fall under this household appliances category or domain. Then home automation and security. This is another area where we are going to use so many embedded systems. For example, air conditioner, okay, a sprinkler. Then we have intruder detection. Whenever somebody enters my house, I want to know who has entered the house. Okay, some unauthorized persons, if they enter, I should be alerted. Such systems are called as the intruder detection alarms. Then fire alarms. Okay, then CCTV, closed circuit television camera. These come under these embedded systems. They fall under this category, home automation and security system. And the next one is automotive industry. Okay, so as you know, in many of the recent automotive vehicles, okay, they are using embedded systems. One very good example is anti-lock braking system, ABS. Okay, so this is useful in rainy season to control the stability of the vehicle. Okay, and they are also using embedded systems to control the engine performance, for triggering the engine ignition. Okay, then navigation, as you all know, Even we have navigation in our mobile phones also. Okay, maps, Google Maps. Okay, so these embedded systems, they fall under this category, that is automotive industry. Okay, then in telecommunication field, the embedded systems are being used are cellular phones. In cellular phones, we are using embedded systems, telephone switches. This is another example for embedded system, routers. So these things are examples for embedded systems which come under this category, that is telecommunication. Then the next one is categories, computer peripherals. Examples for embedded systems in this category are printers, scanners, fax machines. Okay. Then in networking systems, computer networking systems, we have switches, firewalls, okay, routers. They come under this category. Similarly, in healthcare, medical field, as you can see, the doctors may have connected ECG, EEG machines to the patients. They are going to monitor the health of the patient. So all such devices which are used in the medical field, okay, blood pressure monitoring system, ECG, EEG, okay, scanning, CT scanning, okay, all these come under this category, that is healthcare. And measurement and instrumentation, this is the next area where we can use embedded systems. So this already we know in our lab, in the college or in our lab, we are using digital CROs, okay, logic analyzers, PLC systems, multimeters, DMM. So these are some of the examples which fall under this category, that is measurement and instrumentation. So in banks also, they are using embedded systems, that is ATM. As we recently visit, often we go to ATMs, okay, for withdrawing the cash. So automatic teller machine, ATM, okay, currency counters, as you might have seen in the banks for counting the cash, they use currency counters. Okay, so these are some of the examples for embedded systems that are used in this field, that is banking sector. Then card readers, barcode readers, you might have seen in some of the shops. Okay, while billing they use barcode scanners, smart card readers. Okay, this is used in your ATM also. As I put my ATM card, it is going to scan all the details. Okay, then handheld devices. Okay, these are some of the examples for card readers. Okay, these are some of the areas in which the embedded systems are being used. Okay, so let us next move on to why should I use embedded system? What is the purpose of using embedded system? So in the previous slides we have seen embedded systems are being used in so many areas. Then what is the use of that embedded system? Okay, why should I use embedded system? Okay, so based on different applications, okay, the embedded systems may be used for data collection, storage or representation. This may be one of the reasons for using the embedded system. Sometimes embedded systems may be used for data communication. Sometimes the embedded systems will be used for signal processing. Then for data monitoring, we can use embedded systems. For controlling some appliances, we are using embedded systems. Then the last one is application specific user interface. So because of one or more than one reasons which are shown here, we are going to use the embedded system. Okay, so let us go through them one by one. The first one is data collection, data storage or representation. That is, I can use an embedded system for data collection. So what is the data? The data may be voice data, text data, okay, video data, audio data, my speech. Okay, so for collecting such type of information, I can use the embedded system, that is called data collection. The collected data may be analog data or it may be digital data. Okay, so the embedded system is going to collect the different types of data. Okay, that is data collection. Then in some of the embedded systems, what they do, after collecting the data, they may also store the data. And sometimes they also represent the data, collected data that is stored. It may also be represented to the user. Okay, for example, I have my digital camera. Okay, so I have a digital camera. So what all the operations I can do here? I can take a snapshot, I can capture an image. Okay, that is called as data collection. The data is collected, the image is collected. Okay, then it will be stored in the memory of this camera. Okay, so that is storage. The data will be stored here. Then if I want, I can view the picture that I have taken. Okay, that is called representation. So your digital camera is a very good example for all these things. That is data. It collects the data, it captures the image, it stores the image, and it shows me the image afterwards whenever I want to see that. So the digital camera performs all these three functions. That is, it collects the data, stores the data, and it represents the data. So some of the embedded systems may only collect the data, some of them may collect and only represent the data without any storage. Okay, for a good example for collection and representation is our analog CRO. So when I connect my analog CRO to my circuit, what the CRO will do, analog CRO, it will collect the data from the circuit and it will only show me how the signal waveform looks like. It is not going to store anything. So the analog CRO, it only does collection and storage, that is representation, without any storage. It will not store anything. But our digital CRO, okay, it may perform collection, it may also store the waveform, and it will also show me the waveform. So it can perform all the three functions. Okay, so your digital camera also performs all the three functions: collects, stores, and it represents the collected data. So this is one of the reason why we can use the embedded system, okay, for data collection, storage, and representation. The next one is we can use embedded systems for data communication. Okay, so when the data is collected by one of the embedded system, okay, I need to transfer or that move that data from one place to another place. So at that time, some of the embedded systems may be used for data transfer and data reception. Okay, so such type of embedded systems, they are used for data communication. The communication of the data, it may be wired communication or wireless. Okay, the data transmitted by the embedded system, it may be wired or wireless, but nowadays most of the systems are preferring wireless communication because of the ease of the deployment. Okay, so as you can see here, this is one of the example for data communication, okay, where the embedded system is used, that is a internet router is used here. Okay, so wirelessly it can transmit the data. Okay, so this is another reason why we are going to use the embedded system. That is, the reason is data communication. So what are the other examples for data communication? We can use the embedded system in satellites, okay, for transferring the data. Satellite will receive the data from the earth and it is going to retransmit the data after processing it. Okay, so that is another example where the embedded system is used for data communication. Okay, and the next field is, next reason why we have to use the embedded system is for signal processing. Okay, sometimes after the data is collected, I need to process it. So one example for this signal processing is hearing aid. Okay, so this is used by the people who are impaired for hearing. They cannot hear it properly. Okay, so what I need to do, I have to enhance or amplify the signal. Okay, so for that reason, we can use such systems where it is going to amplify the signal. Okay, then it will be reproduced. The signal, amplified signal, will be reproduced. Okay, so for processing the signal, I need the embedded system. Okay, the hearing aid. Okay, what we call it as. Okay, this is also one of the very good example for embedded system used for data processing. Okay, so this is one more reason where we can use the embedded system for processing the signal or the data. Okay, and the next one is the embedded systems are used for monitoring the data. Okay, so as you can see here in the image, it is a monitoring system for heartbeat. Okay, as you can see in some of the medical fields or some of the hospitals, the doctor wants to monitor the heart rate of the patient. So it will be shown digitally here. So some sensors will be connected to the patient, and after sensing that data, this system is going to show, okay, what is the heartbeat rate. Okay, based on this, the doctor can take the further decision on medication. Okay, so in this field also we can use embedded systems. Okay, so just remember, in monitoring, the embedded system will only represent the data, collect the data, represent the data. It's not going to alter the data. Okay, just remember that. And the next reason why we can use the embedded system is for controlling. Okay, A very good example for controlling is your air conditioner. The air conditioner is used for controlling the temperature of my room. Okay, so it has sensors. The air conditioner has sensor. Okay, so whenever I set the temperature through my remote, the sensor is going to sense that value that is sent. Then it is going to activate the compressor inside this AC for controlling the room temperature as per the set value. Okay, so the AC is going to receive my data and it is going to set the temperature, or it is going to maintain the temperature, room temperature at the specified value. So in this way I can control the temperature of my room. So this is one of the reason why I can use the embedded system for controlling something. Here I am controlling with help of AC, I am controlling what? The temperature of my room. So in this way embedded systems can be used for controlling the some of the physical parameters. Okay. Then the last one is application specific user interface. So some of the embedded systems are using application specific user interface. For example, in our mobile phone I am using what? This LCD screen. Okay, so this LCD screen along with its driver software, it acts as an user interface for this phone. So I can interact with the phone by using this LCD screen. Okay, so this is also in the phone itself. There is it is an embedded system, but inside this embedded system there is one more embedded system, that is LCD screen. Okay, through which the user can interact with the phone. Okay, so this is another reason why we are going to use the embedded system, that is for interacting with the user. That is called user interface. Okay, so based on the particular application I am going to design the interface, that is called application specific user interface. Okay. What are the examples for this application specific user interface? It may be an LCD, or it may be a speaker. Okay, or there may be a vibration alert. Okay, keyboard. These are some of the examples for this application specific user interface embedded systems. Okay,